So let's leave this and I am moving forward. So we have completed this question.
Yes, sir.
Parallel plate capacitor with dielectric partially filled between the plates. So now energy stored in capacitor. Energy stored in capacitor. So the derivation is not in your syllabus from this year. Okay. Derivations is not in your syllabus. So I am writing directly the formula. So this is parallel plate capacitor. These are two parallel plates, positive charge, and this is negative charge. So initially what happened, first we have these only two plates. Okay, this is the initial stage. We have only two plates. These plates have no charge and these plates are separated by some medium. And finally what happened, and we have connected these plates with a battery. This is a battery. We have connected these plate with a battery, and this battery will give the charge to these plates and will charge the capacitor. This is the capacitor. This battery will charge the capacitor and we will get this is one plate, this is another plate. So here we will get some positive charge, okay, and here we will get a negative charge. After connecting to the battery, negative charge. And suppose Q is the charge given by battery. Q is the charge given by battery to the capacitor. Now the charge on the plate of the capacitor is on the positive plate Q, and here is minus Q. And C is the capacitance of capacitor. So the formula there is the formula is only in your syllabus. Derivation is not in your syllabus. So energy stored in the capacitor can be written as, I am representing energy in the stored in the capacitor by capital U. So capital U is Q square upon 2C. This is one formula, first formula that you should remember. And another is energy when you will substitute the value of Q here. Like you can write this, I can write Q equal to CV, and I will square that C square V square divided by 2C. So I can write it half CV square. So I can write this as U is equal to half CV square. This is another formula. So from here, this is half, and I can write C as Q by V, and this is V square. So from here, I will get half QV, half QV. So U is equal to half QV. This is another formula. These are the formulas for calculating the energy stored in capacitor when a charge Q is given to the capacitor, and where V is the potential difference. V is the voltage or potential difference. Voltage, or you can say potential difference. Potential difference between plates of capacitor. These are the formulas. Now next term is energy density for parallel plate capacitor. Energy stored in capacitor. Now energy density. Energy density. And this energy density is represented by small u. And this small u is energy stored. Small u is energy stored. Energy stored in the capacitor divided by the volume of capacitor. So here is the capacitor. Negative. And A is the area of plate. And D is the distance between two plates. So volume of this area into distance, AD. I can write volume as AD. So we have the formula of energy. We have the formula of energy, Q square by 2C. Earlier I have discussed. And for the volume, I will write AD. So this is a small u. Okay, this is a small u. Small u. So here from here I can write Q square 2. And what is the capacitance of parallel plate capacitor when air is between the parallel plate capacitor? Epsilon naught A by T. So I am writing here instead of C, epsilon naught A divided by T, and this is AD. So I can write this as A into D. So from here, this D and D get cancelled out, and we have Q square by 2, and this will become A square, 2A square. And we know that sigma is equal to Q by A, and sigma square is equal to Q square by A square. So from here I can write, and there is one more term here, epsilon naught. Okay, here epsilon naught is also there. So from here I can write Q square by A square is sigma, and this is 2 epsilon naught. Now I am multiplying epsilon naught in numerator and denominator. So I will get, this is sigma square, sorry. So I will get is equal to sigma square divided by 2 epsilon naught square into epsilon naught. And I have told you electric field between the plates of capacitor is sigma by epsilon naught. I have discussed this many times. So from here I can write half, instead of sigma square epsilon naught square, sigma square epsilon naught square, this will become E square sigma square. What is happening here? Half epsilon naught into E square. This is the formula for energy density. Got my point, Nawal?
Yes, sir.
So please note it down. क्या हो रहा है यार?
Very school. Very school.
Fine.
Yes.
So there is only requirements of formulas. We will solve the numerical, then you will understand. Now from this year, the derivation is not in your syllabus. Actually, the calculating of electric field in between the plates of capacitor, you should remember the formula. This formula is very, very important. E is equal to sigma y epsilon naught,
Yes, sir.
total electric field.
Very school.
I have substituted the value. See here, C is this, and now placed here, and here this is cancel out, and this is small u. Small u is energy density.
Done, sir.
Done. Okay. This one done now from here.
Yes.
So now there is a question. Now we will calculate the force between the plates. Force between the plates. Force between plates of parallel plate capacitor. So this is these are two parallel plates. These are two parallel plates and separated by some distance d, positive charge, negative charge plate, and we will calculate the force between these two plates. So first calculate the electric field in between the plate. We know the formula. Total electric field between plates is sigma by epsilon naught, and sigma is given by q by a, q by a epsilon naught. So we have electric field q by a epsilon, and here is we know here is charge q and here is minus charge q on this plate. And if I want to calculate the force on any charge, if I want to calculate force on charge plus q, so we have a formula. Force is equal to charge into electric field. F is equal to QE in electrostatic. So force F is equal to charge into electric field E. This will become Q square divided by sorry, actually we have done a mistake. For this plate, if I am calculating the okay, no problem. So I want to calculate I want to calculate the force, suppose on this charge, on plus q charge. Means these are two positively charged plates and these plates will attract with the same force F, and this F we have to calculate. So if I want to calculate, I should calculate the charge means force on any of the plate, and that force will be equal. So suppose for this plates, due to this plate, the value of electric field is 2 electric field due to plate 1. This is plate 1 and this is plate 2. So right here, electric field due to plate 1. And we have already discussed the formula for a single plate. I have told you the formula for a single plate. The electric field is sigma y 2 epsilon naught. So here sigma y 2 epsilon naught, sigma y 2 epsilon. So this is the electric field. This positively charged plate will generate the electric field, and due to this electric field, this minus q charge will experience a force, and this is a force. This is a force on charge minus q. This is a force on charge minus q. So here uh, you can take the charge. This is very simple. Force on charge minus q. So we have a formula. Force on the charge minus q means charge minus q into the external electric field created by positively charged plate, and I am representing this with E. So this is minus q into E is q divided by 2a epsilon naught. 2a epsilon naught. So force is equal to minus q square divided by 2a epsilon naught. And if I am talking about only the magnitude of force, magnitude only, then F will become q square divided by 2a epsilon. So this is the force in between two parallel plates. You can do one thing more. You can do one thing more. You can calculate the electric field due to this plate and take this charge and calculate the force on this charge. Then also you will get the same result. So please note. These are the concepts of electrostatics. Means this is the electrostatic, but these are the concepts of electric field and charges. We know that whenever a charge comes into electric field, hmm, whenever a charge enters in the electric field, it will experience some force, and that some force is given by the formula force is equal to charge and the electric field. So please note it down.
Can you scroll? Done, sir.
This is the question. This is the question. The plates of parallel plate capacitor have area of 90 centimeter square each and are separated by this. A is given, D is given, and voltage is given. Charged by connecting to a 400 volt supply. How much we have to calculate U, capital U and small u. Simple. So in the first case, we have a capacitor and this capacitor is connected to a 400 volt supply and D is given by, what is D? D is 2.5 mm. So 2.5 mm, 2.5 into 10 to the power minus 3 meter. And area is 90 centimeter square. So 90 into 10 to the power minus 4 meter square. Calculate the capacitance. And air is in between the plates. Epsilon naught A by D, right, put the value of epsilon naught 8.85 into 10 to the power minus 12 into area 90 into 10 to the power minus 4 divided by D, that is 2.5 into 10 to the power minus 3, and you will get the answer 8.85 into 36 into 36 into 10 to the power minus 13 Farad. So you can calculate this by yourself. And we have to calculate the energy density, U in the first case. U is equal to, you can calculate it half by half CV square. We have a formula. So half, put the value of this capacitance, 8.85 into 36 into 10 to the power minus 13, and voltage ka square means 400 square, and you will get the answer you can calculate this also. So this is done, half CV square C into V square. And in the B part, we will calculate a small u, and a small u is given by half epsilon naught into electric field square. And what is electric field? Electric field is sigma by epsilon naught, and sigma is q by a, 2 by a epsilon naught. So we have this one, we have this one, we do not have q. So we will calculate the value of q. So for that, what we will do for calculating q, q means charge on the plate of capacitor. We have the formula of this half qb. U can be written as half qb. Capital U can be written as half qb, and this can also be written as half cv square. This can be written as half cv square. So half and half cancel, and from here you will get, you can simply put the value of Q here. Put the value of U. What is the value of U? U is this half 8.85 into 36 into 10 to the power minus 13 and 400 square. 400 square equal to half QV. Half Q, and what is V? V is 400. So when you will calculate the Q, so Q will come out to be 8.85 into 72 into 10 to the power minus 13 coulomb. Okay. So now we can calculate the electric field. Electric field is given by, I have written the value of electric field Q upon A epsilon naught. Q upon A epsilon naught. Put the value of Q minus 13. Area is 90 into 10 to the power minus 4, and epsilon naught is 8.85 into 10 to the power minus 12, and the electric field will come out to be 800 volt per meter. And now finally we will calculate small u half epsilon naught into E square. Half value of epsilon naught is 8.85 into 10 to the power minus 12 into value of E square, means 800 square, and you can calculate this by yourself. So this is the question. Please note it down. So what I have done, first I have calculated the capacitance, and from that capacitance I have calculated the charge on the plate of capacitor. Charge on the plate of capacitor. And from this charge I have calculated the electric field, and from the electric field I have calculated the energy density. So you should know the formulas only. Capital U have three formulas: Q square upon 2C, half CV square, half QV, and energy density as formula half epsilon naught into electric field square. Are you getting my point, Nawal?
Yes, sir.
So these are just formula based things. And only these kinds of questions will be asked in your examination.
It's good.
Okay. So whenever there is capacitor, there will be a charge. And in your syllabus, there is parallel plate capacitor. So take the equal charge. One plate have Q charge and another plate will have negative Q charge. And accordingly, you should learn the formulas and simply put the values in formulas and calculate that. In the examination, the calculation will be easy. These kinds of calculation will not come in examination. So,
So can we go?
okay. Fine.
Yes, sir.
Okay. Nawal, in 12th, you have mathematics or biology?
I have bio.
Biology.
Sir.
So, do you want to become the doctor?
Yes, sir.
Very good.
Done, sir.
Done. I am taking a break of 1 minute. So, hello.
Hello, sir.
Oh, okay. So now we will start a very important topic. Parallel plate capacitor parallel plate capacitor with air between plates. Air between plates and connected with connected with battery battery of of voltage uh, voltage of V naught of voltage V naught and this battery remains connected. This thing is very important. Remains connected. So let's see. Uh, this is the parallel plate capacitor. This is a plate and this is another plate. These are parallel plates and these parallel plates are connected with the battery and this is positive terminal because this is negative terminal, so means this plate will have positive charge all over the plate and this plate have the negative charge and this battery have the V naught voltage V naught. So always remember this thing. Always remember this thing. Whenever the battery remains connected, So whenever the battery remains connected, it means that the potential difference or voltage across the capacitor will remain same, will not change. क्या हो रहा है यार? So here is a capacitor, and this capacitor is now connected with battery of V naught volt. So in this case, always remember this, voltage, and voltage is also known as potential difference. Potential difference between plates will remain same, will remain same. This is only when the battery remains connected. So now if I am saying I want to calculate the capacitance, and here is air in between the plates. So Nabal, please tell me the formula of capacitance.
So what did you ask?
Okay. I am asking that please tell me the formula of capacitance.
Epsilon 0 A by
Okay, good. So capacitance, if we want to calculate, epsilon 0 A by T. So capacitance will remain same when battery is connected. And voltage V, if I want to calculate, then this will also equal to V naught, remains same till the battery is connected. And third charge. So for calculating charge, we will use formula Q is equal to CV. And if I want to calculate the charge, so what is capacitance here? C naught, and this is V naught. Okay. So you can write for the charge, if charge is Q naught, I am supposing. So charge Q naught is equal to C naught into V naught. Fourth, energy stored. Energy stored is represented by capital U, and we have formula of capital U half CV square. And please remember one thing, if all the things are, means if the plate of capacitor, in between the plates of capacitor, if there is air, we will represent all the things with this zero. Like capacitance will be written as C0, voltage will be written as V0, charge will be written as Q0, okay, C naught into V naught. This is the symbol I use when the air is between the plates, like you have seen in the Coulomb's law also. In the Coulomb's law, here is a charge Q1, here is a charge Q2. If someone says calculate the force when there is air in between the charges, so what do you do? For upon 4 pi, here you use epsilon naught always,
So,
and Q1 means you can, and this is R square. And for medium, we use Fm is equal to 1 upon 4 pi epsilon naught m. Means for medium means there can be the these are the plates of capacitor. In between the plates of the capacitor, there can be air, there can be water, there can be vacuum, there can be oil. Okay, there can be any medium. So this is the case. Now this is the case when battery remains connected and this is very easy case. Okay, no problem. So now you can see a parallel plate capacitor. Now I am filling it with dielectric. Filling it with dielectric. With dielectric between plates and connected with a battery of voltage V naught, and this battery remains connected. All the things remain same. So this time this is the capacitor and this is connected with battery, and now this capacitor is filled with some dielectric, and dielectric with dielectric constant. The dielectric has dielectric constant K. Okay, dielectric constant K. So now, and again in this case battery remains connected. So if the battery remains connected, first thing is voltage, or you can say potential difference. Potential difference will always remain same. That is V naught. Means across the plates, the voltage will remain same whenever the battery is connected, no matter what you are filling in between the plates. So if I want to calculate the capacitance, if I want to calculate the capacitance, so now there is a medium in between the capacitance, so I am representing capacitance Cn, and we have a formula of capacitance. This will become K times of C epsilon naught. We have discussed. Okay. Capacitance will not will change accordingly. K times We have discussed this thing also in previous classes. And means capacitance is increasing. Cm means you can say increasing. Why increasing? Because k is greater than 1. That's why increasing. Number second, if I want to calculate the voltage, so this will remain same. That is V0. Why remains same? Because battery is now connected. Third, I want to calculate the charge. Now, what about the charge? I have told you now we are calculating the charge between the parallel plate capacitor which are in some medium. Then Q is equal to, we will use capacitance of medium and potential of plates in medium. So Qm equal to Cm. What is the value of Cm? Cm is K times of C naught, and Vm is equal to V naught because potential is not changing. So this will become K times of C naught V naught, means you can say K times of Q naught. Q naught is equal to C naught V naught, means charge will also increase. Charge will also increase. And last thing is, if I want to calculate the energy stored, energy stored in the capacitor, energy stored in the capacitor. So earlier we are using capital U into 0 because the plates are in air. Now I am using UM because the plates are in some medium. So formula will be half Cm, capacitance is medium, into potential is medium square. So UM is equal to half. Cm is K times of C naught. Vm is not changing. So you can say this will become K times of U naught. Means this is also increasing. Nawal, are you getting my points or not?
Yes, sir.
If you have any, these are very simple things. I am doing nothing. All the things are done by formulas. Formulas are doing everything. Yeah, I am doing nothing. So, this is very important question. When the battery remains connected, what will happen to the capacitor? What will happen to the potential? What will happen to the charge? What will happen to the energy? So don't try to mug this. Means try to understand. If someone says calculate the charge, so don't learn this. You should understand how to calculate the charge. Write the formula. What is the formula for charge? Charge is Q is equal to capacitance into voltage. If I am calculating the charge in medium, then I will take the capacitance of medium and voltage of medium. So that's how you can calculate. So please note it down from here. And Nawal, please tell me one thing. How many hours we have in a day?
24.
24 hours. Okay, very good. You can note, we will talk also. So we have 24 hours. And if someone is sleeping 10 hours, So now how many hours we have?
14.
Very good. 14 hours. And this is your vacation period.
Yes, sir.
Okay. So from these 14 hours, after enjoying 10 hours, if you are enjoying, I don't know, 10 hours enjoyment is, I don't think anyone can enjoy 10 hours. We have 4 hours. Okay. We have 4 hours now.
Yes.
And after enjoying 10 hours, now we are enjoying 2 more hours. More hours. And after this, how much hour we have left?
Mm.
2 hours, no? So we have to give this 2 hours to our study. Okay, please note it down. Should I scroll down?
Yes. Can you scroll, sir?
Now fine.
Yes, sir.
This is the symbol of battery or cell, you can say. A battery is a combination of cell.
Can you scroll?
Okay.
Can you scroll?
Okay. Okay. So whenever the battery remains connected, the potential across, or potential is also called as voltage. So voltage will remain same no matter what you are filling in between the plates. And now what we will do, we will remove the battery and we will see what happened when we will remove the battery.
Sir.
Okay. So Nawal, you have not got the assignment on the portal.
No, sir.
You don't know what is portal. You know about portal?
No, sir.
You don't know.
No.
Okay. So this is the first case. Can write this as a first case. First, this is second, or you can say this is as third. So now what I am doing, dielectric remains dielectric inserted fully. In the above case, we have inserted dielectric fully, not partially. So dielectric inserted fully and battery disconnected. Now this time battery is disconnected. Battery is disconnected. So battery is disconnected means what will happen? This is the parallel plate capacitor, and someone taken out the battery from it. Someone taken out the battery from there. Now no supply, no supply, no power supply, supply of power or energy, you can say. No supply of power or energy, and dielectric is filled. So this time we have a parallel plate capacitor. Earlier the air in between the plates of capacitor, and what we have done now, firstly we have connected this with battery. Okay, firstly we have connected this with battery, and after that we have connected this with battery, and battery remains connected and dielectric is filled. Now the case is dielectric is filled, and after the battery is connected, now the battery is removed. And one thing, remember one thing, uh, whenever the battery is disconnected, charge will remain same on the capacitor. charge will remain same on the plates of capacitor. Why the charge is on the plates of capacitor? Why the charge? Because now what is the work of the battery? The work of the battery is to give the charge. Battery is giving the charge. Now you have disconnected the battery. Now charge is not anything is not giving charge to the capacitor. So means the charge will remain same on the capacitor. Suppose this is a capacitor and battery has given the charge of plus 2 coulomb. Now you remove the battery. Now you have removed the battery. Battery is removed. So this charge will remain same. No? So this is the case. And now if I want to calculate the capacitance, for this case. So whenever the dielectric is inserted, the capacitance is K times of capacitance in air. And C naught, we know the formula of C naught. Epsilon 0 into area of plate divided by distance between plates. So means capacitance will increase. Capacitance will increase. And now I want to calculate the voltage. Earlier the voltage was constant. Now we will see what will happen to the voltage. So V naught is a voltage in air and Vm is a voltage when dielectric medium is placed. So formula for Vm will be Qm by Cm. So Vm is equal to Qm by Cm, and I have told you charge will remain same. Charge will remain same means charge will remain constant Q naught. Charge is constant Q naught. Q naught means it is same as the plates have the air and battery is connected. Like here you can see. Initially we have taken the charge Q naught. Now, okay. So charge will remain same. So we have charge. You can write charge as Q naught remains same. But what about the capacitance? K times of C naught. This will increase. So please tell me, Vm will increase or decrease? Vm will increase or decrease? If
Please.
if charge is same, and this capacitance is increasing, so Vm will increase or decrease? Are you getting my point? I am asking Vm will increase or decrease?
Decrease.
Okay, very good. Vm will decrease because here new denominator is increasing. Fine, very good. And now third point is this is third point. Now if someone want to calculate what is the charge on the plates of capacitor, so charge will remain same as before. Charge will remain same Q naught. We have discussed here. And fourth point is, if you want to calculate the energy, this is energy in air, This is energy in medium, and this is given by half C of medium into V of medium का whole square. So UM is equal to half. Cm is K times of C naught, and Vm, from here I can write the value of Vm, Q naught divided by K times of C naught. So this C naught and this C naught is cancel out. So, and okay, this is the square. This is the square. So this will become half K, and Q square means Q naught square divided by 1 K square C naught square. Okay, do this again. Do this again. Half Cm, K times of C naught, Vm square means Q naught by K of C naught square. So open the square, half K times of C naught into Q naught square divided by K square into C naught square. Now C naught and C naught cancel out. This C naught is gone. We have, and K is also gone. So we have U energy half and Q square upon C, Q naught square upon K into C naught. So I can write this. Energy will become U naught times of K. So this time UM will increase or decrease. UM will increase or decrease. Nawal, I am asking something.
Increase.
Increase or decrease?
Increase.
This one? Decrease?
Yes.
Very good. Why decrease? Because K is greater than 1. Decrease. Very good. Because K is always greater than 1. When we divide, then this will be decrease. Okay. So please note it down.
So we can start.
Okay. So please remember, whenever the battery is disconnected from the capacitor, charge will remain same. And battery remains connected, potential will remain same.
So can you scroll?
Okay. And please revise your notes.
Done, sir.
Okay, done. And that's all for today. And please revise your notes. Okay.